Okay, so let's finish this last part of chapter 17. So last time we talked about thunderstorms. Hail is a component of thunderstorms. Let's see if I can get this to, there we go. Hail is officially classified as frozen precipitation. We know that it can form in various sizes, can be pea size all the way up to softball size. Irregularly shaped, spherical, or flattened forms. And we know that, so if you're not sure the way, or if you don't know, the way that hail is formed is once it starts to fall from the cloud, it's going to go through periods of warm and cool and warm and cool. So it's going to melt, freeze, melt, and freeze. And the higher the cloud, the more of those repeated patterns it's going to go through. Therefore, the bigger the hail is going to get. If the storm is very small in size, not very high up in the atmosphere, then what's going to happen is it's only going to go through that growing process for a little bit before it falls down and hits the ground, which will make it smaller hail. And so because of the way it's formed, hail is alternating layers of clear and opaque ice. Okay, so you see some hail right here. Kind of looks like maybe Sonic ice, which right now I'd give anything to go to Sonic. Tornadoes are going to be our smallest. So we say smallest, and that makes them sound insignificant, but it's a focused amount of energy, which makes them very, very severe at times. Well, really all the time. It just depends on where they hit and the severity. And they are our most violent weather disturbance. It's the smallest and most violent weather disturbance. It is a rapidly whirling column of air, and that column is the low pressure system drawing up the air inside the funnel of the tornado up into the atmosphere. And so when a tornado passes over something that it can be pulled up from the ground, it's going to throw it up into the atmosphere, and it can throw things for miles, 40 miles, 30 miles. It can very easily distribute things and people and stuff like that. The diameter of a tornado can be anywhere from 100 meters to 400 meters. So if you're thinking about a meter stick, that is roughly the same-ish size of a yardstick. And you can think of 100 of those, right? So they can be very wide. 100 yards would be one football field. 400 would be 4 football fields. The wind speed can be up to 480 kilometers per hour, so that would be the strongest tornado winds. Most of the damage is produced by the high winds of the tornado, the severe drop in the pressure, and then flying debris. So I remember when I was a kid, there was a tornado in Jarrell, Texas. It was right around the same time, and this is strange that I know this, right around the same time that Selena was murdered, which was 1995. And I only know that because we learned about the Jarrell tornado. And when Selena died, I was at a day camp as a kid, like a summer camp. And I remember the people being very upset. But I also remember learning about the Jarrell tornado. So I'm not sure exactly when it happened, but I correlate those two things together. But the Jarrell tornado still to this day, I believe, holds to be the strongest tornado that has ever hit Texas. And I think it was a 5A tornado. And I don't even know if I just said that right. 5A tornado. EF5, not 5A. I got this mixed up with school classifications, but EF5 tornado, which is the strongest tornado. And it passed through Jarrell, Texas, and I mean, it did terrible destruction. And I remember them telling us a story about how they found a boot and like a man's shoe, and there was a foot inside of the boot. Now, the foot belonged to the shoe, but they didn't find the rest of the body. And it was just, that kind of imagery for me was very strong. Obviously, probably is for you too. But you can see trees get broke down into little bitty splinters, and then those splinters are getting thrown at hundreds of miles an hour. They become like weapons. So damage with a tornado is very, very likely, which is what makes them such a scary weather phenomenon. Now, luckily for us, tornadoes are associated with very intense thunderstorms. They typically don't happen if you just have a summer rain. Remember, thunderstorms have to have the very warm, very moist, and very unstable air. And so we know typically when the conditions are ripe for a tornado. We just can't predict when, we can't predict where, we can't predict the size. That's it's unlikely that we'll ever really know all of these things in meteorology. Now, hurricanes, and I will say Tornado Alley historically was from the plains of like Lubbock up through Amarillo, up into Kansas. But in the last 30 years, we've seen that the Tornado Alley has shifted. It's actually to the right now, and it runs up, instead of through the plains, it runs along Dallas, Fort Worth. And we are on the easternmost edge here in East Texas, which I thought was strange because I grew up learning about Tornado Alley being a Central Plains thing, Kansas, Kentucky. But we've seen that the alley is shifting to the right, and it means that tornadoes are now happening in a different area more often than they were before. And what this means long term, we haven't really been recording weather long enough to know what will happen, if it will go back, if it will continue to shift further. But here we are, we're likely to live in a world where tornadoes are more common to us than they used to be. And having trees makes that a scary reality. We've seen the tornado there in Nashville just a few weeks ago. Tornadoes, we've seen them in Terrell and in Canton, and so we know that they're becoming more common, the one over in Ruston, Louisiana. And this is not something that historically was a problem in these areas, maybe rarely, but we're seeing the size increase and the number increase as the years go on. So hurricane is another thing that we deal with here in Texas. Now, mainly along the coast, the big thing about where we are here in Marshall when we have hurricanes is if the hurricane is strong enough to make it landfall and transition back into a tropical storm or tropical depression, and it travels over East Texas, because we have an area of lots of rivers, a lake, and we usually have more water than we need. If we receive the rain from a hurricane that has come into land, we are likely to flood. And that's the extent of usually the hurricanes that we will see. But we are located directly over Houston, and we have several students from Houston area. And so you guys are familiar with hurricanes probably more intimately than I am, because I grew up in Bastrop, which is outside Austin. Again, not an area very heavily affected by hurricanes directly. So we have three phases of a hurricane system. The first is called a tropical depression. These are usually the ones that we just kind of note that they're out there. They're an area of low pressure. The winds are usually 55 kilometers or less, not very intense storms. We don't even name them, we give them numbers. When it becomes a tropical storm, now we start naming them. We give them names, we monitor them. They're an area of more intense low pressure. The winds at that point will go from anywhere from 56 to 120 kilometers per hour. Tropical storms can still do some significant damage, but it tends to be not as severe, not as much rain, not as long lasting. It's just kind of an immature adolescent storm. So not very, oh my gosh, I hope y'all did not just hear my stomach growl. I think I said the thing about Sonic, and it got me all thinking about Sonic. Okay. The hurricane, on the other hand, are the storm systems that we absolutely name. Every year we alternate. Don't know if y'all know this, but every year we start at A, and we alternate male and female. So, A, the one year might be Andrew, and then the next year A is going to start, and it might be Anna. And then it alternates. And so I, growing up as a Marissa, always wanted to have a hurricane or a tropical storm named after me, but it's very hard to make it to the M's, which is great. We don't want to make it to the M's. But they named them in order of when they transitioned to become a hurricane. So once a tropical storm becomes a hurricane, they're going to give it a new name. But that doesn't always tell us anything about whether or not it's going to make landfall or be severe, or, it's how we track them. Now, hurricanes are very intense. The winds can just start at 120, but you can see there's really no upper limit. We've clocked hurricanes at very, very high winds. They're fully developed when they have, when they are fully developed, they will have a calm eye. You can see that in this satellite image right here. This looks like this is off of the western part of Mexico. This looks like Baja right there, kind of sticking down on the tail. And they're going to be surrounded, that calm eye is going to be surrounded by intense rain and thunderstorms. And so when you live in an area like Florida or an island where the hurricane can pass over, what you'll know is when a hurricane is coming in, usually the wind will be blowing in one direction. And then once the eye passes over you, the wind is then going to reverse and go the opposite direction. And that's reflecting the counterclockwise rotation of the hurricane. Okay, so these are counterclockwise systems. All cyclones are counterclockwise. The anticyclones are clockwise rotation. So if you're looking here on the bottom right-hand image, you're going to see that the eye is an area where there's no wind, no rain. It's very calm. And then the clouds around it kind of make a mushroom-like shape, and you have the upward pull of the clouds, and then the very calm eye, it's going to push down, but it becomes kind of like a cyclic process, and then you'll have rain pointing in the directions. And we know that hurricanes can drop a lot of rain. The side of the hurricane you usually don't want to be on is, I think, the eastern side, because that's where the majority of the rain is being dropped, and the western side of the hurricane is usually the better place to be. But don't quote me on that, but I feel like I learned that in my weather and climate class. Okay. So weather forecasting, many people have problems with meteorologists because they feel like they're kind of like the canary in the landmine, always causing or calling for severe weather and nothing happens. But meteorology is not a science that's easy to lock down, because there's a lot of variables which we still don't really understand, even with all the computers we have. So what weather forecasting relies on is, one, knowledge of a meteorologist, and two, it's based on mathematical models of the atmosphere. So computers monitor this. It comes from people who call in and report local weather, or weather stations which monitor weather, and then NOAA, which is a larger organization, will monitor that on a bigger scale. So like Shreveport's one of our NOAAs. There's one in Dallas. There's one in Norman, Oklahoma. And so they all kind of contribute, and they all have different types of radar which help us to detect it, but it's still just based on math that we don't really understand. There are billions and billions of calculations that are done by supercomputers to produce results for weather forecasting, which is what makes it such an uncertain science. Now, the accuracy of a weather forecast is limited at about 3 days. So if they say it's going to rain tomorrow, fairly good chance that's correct. If they say it's going to rain next week, or in 10 days from now, or 2 weeks, we don't really know that. It's impossible to say with certainty that we know that. But we can get pretty accurate within 3 days, which gives people enough time to go and buy all the toilet paper and all the paper towels from the store, all the water. Now, where the uncertainty comes from is that we have kind of insufficient technology to connect the small and then the large scale events. So looking at weather, like saying, okay, I'm only going to focus on the Arklatex weather. Well, the reality is the Arklatex weather is influenced by what's happening over in Seattle and Washington, what's happening down in Mexico. And it's just, there's too many large events that are also significant for us that you can't ignore. And that's what makes it so hard. There's too many facts and data to possibly predict all of it. And then there's also a factor of the ocean that we really don't quite understand. So we don't really understand how the ocean influences our local weather enough. But it's a science that we're learning more about. In fact, I remember learning in my weather and climate class in undergrad, which was probably 10 years ago, no, way more than that, 14 years ago, that we'd only been really even recording weather for 30 years. So we've only been collecting it regularly for about 45 years, and that's just not a lot of time to really understand it. And then it's also changing. Tornado Alley is moving, and that's an example of what makes it hard to predict what's going on each and every day. Now this brings us to talk about climate. So climate is the composition of larger weather patterns occurring over a number of years. So this is where people get something like climate change and weather mixed up. Weather is what's happening today and tomorrow and yesterday. That's weather, and that's local. That's you individually. You might look out your window and maybe it's sunny today. It's not sunny here. But that doesn't mean we live in different climates. We still live in the same climate because you're probably in Texas or in Louisiana, and we're not that far apart. But what's different is that our weather is different. So climate is a long-term average, a long-term observation. And climate has a determining factor in the types of plants and animals that grow and live at a condition. The pine trees that grow here typically don't grow over in West Texas. That's differences in climate. That's not weather. That has nothing to do with weather. It's an accumulation of weather over time, but it's the climate that dictates where plants are going to grow, where they're going to prefer to grow. The types of houses that are built. The houses that are built in New Mexico look a little bit different than the houses that are built here. That's climate. They tend not to have beautiful watered yards. They tend to have rock yards because grass doesn't grow there and it takes too much water to get it to grow. And then also lifestyles. Up north, where they have a very long, hard winter, they tend to not be as active outside as we are down in the south, like fishing and hunting. And that's a southern thing because we have the weather to accommodate those lifestyles because it's our climate. Now, the other influences is it influences the shape of the landscape, whether that's very green and wet and lots of rolling hills because of the streams, the types of soil, whether you have clay, silt, things like that, and then the agricultural type and productivity. So in West Texas, they're going to grow cotton, things like that, but it takes a lot of irrigation. Cotton's actually a pretty hardy plant, but you're not going to grow something like a lot of vegetables where you need a lot of rain, and there's just not rain there. Okay, so it determines what type of agricultural things you're going to see there. So there are two primary factors in defining our climate groups. The first is the intensity of the incoming solar radiation. So remember we talked about if I told you to take your flashlight, put it up against the wall and see that the light's very intense versus tilting it and how it disperses that light. So that dictates our climate zones. The equator, very tropical. The poles, very not tropical, very polar climates. And so that difference is also contributing to our climate groups. The other part is the number of daylight hours. So you may know this, but up in Alaska, they have periods where it's 24-hour darkness, and they live there. Like the sun never comes up, and they still go to college, and it's dark all day. And then they have periods where it's daylight all day. For 24 hours, the sun does not go down, and they still go to sleep. That doesn't happen here. We have a pretty normal pattern. I think we get, at the most, it's like 18 hours of, and I may be wrong, but I think we have a period where we get 18 hours of daylight, and then maybe it's considered 13 hours or 15 hours of darkness. But we keep it pretty half and half on average. So those are what influences our climate zones. Now, the climate zones are going to be defined in the terms of yearly average temperatures. So they're going to take the temperatures along the zone, and then they're going to average them and say, okay, this zone has about the same average temperature. This zone has about the same average. And what that produces is 5 bands across the globe. We have our polars at the top, our tropical at the equator, and then between the polar and the tropical, we have what's called a temperate climate. So the tropical climate zone is near the equator, receives the most direct, intense solar radiation, very hot. It's where things like the Amazon are, the deserts, the Sahara Desert in Africa, which fascinating stuff happening with the Sahara Desert. If you haven't heard about what's happening there, I think you should look into it. We're not going to cover it, but the Sahara Desert's going through some major changes as a result of climate change. The polar climate zone, these are our poles, North Pole, South Pole. You see that Greenland exists in that, as well as Antarctica, which are continental glaciers. They receive the least amount of solar radiation. They're very cold. They even have constant daylight for part of the summer and then constant darkness in part of the winter. And so you'll see that parts of Alaska are fully in that, but then they're, I think maybe fully in there. But then they're close enough to the border where they have very long days and very long nights. The temperate climate zone is us. We are in the temperate zone, so even though it feels hot here, we are nowhere near the tropics, and even though it can feel cold here, we're nowhere near the polar. But we kind of have a mixture of both. Sometimes it's cold, sometimes it's hot, but most of the time it's considered mild on average. And that goes all the way across the southern part of Africa, the southern part of South America, except for the very tip, and then the majority of Australia falls in that temperate zone. So this is all of chapter 17. You were supposed to finish up this part today, and then we'll do just the very first little bit of chapter 18 and finish chapter 18 on the next day that we quote unquote meet. I hope you're keeping up with everything. Please understand that if you need anything, you can communicate that with me through email. You have my phone number, text message, whatever you need to do. I want to make sure I'm still helping you guys, answering any questions you may have. Just don't hesitate to reach out.